thinking now. Okay, so one-sided derivatives. So we looked at this a little bit, yes?
I don't think. Well, we did it in that homework problem, but
Right, yeah, the homework problem was
Yeah.
meant to be a think about this and see if you can figure it out.
Yeah.
But now that we've done it, here, let me give you the notes on it. And every now and then that's going to happen. I'm going to be like, yeah, go get him. And you'll be like, I don't have all the information. I'm like, yes, I know. See what you can figure out or find out. So the limit as h goes to 0 from the right of f of a plus h minus f of a over h is the right-hand derivative at a. And the limit as h goes to 0 from the left of f of a plus h minus f of a over h is the left-hand derivative. So just like it was for other limits, if the right-hand derivative is not equal to the left-hand derivative, then the derivative does not exist. Or if either one of those individually doesn't exist, you can't have two things that are equal if one of them doesn't exist, right? Okay, so let's look at one that's, well, pretty similar to the one we just did. Show that f of x equals x squared for x less than or equal to 0 and 3x for x greater than 0 has left-hand and right-hand derivatives, so it's different than the one that you guys asked about, because that one had, what, a right hand but not a left hand, or was it the other way around?
No right.
Had no right hand, but it had a left hand. Okay? This one is going to have a left hand and a right hand, but they're not going to agree with one another. Okay? So let's start with the left hand. So the left hand derivative we're going to take the limit as h goes to 0 from the left of f of 0 plus h minus f at 0 all over. You don't have to write 0 plus h minus 0. I just do that to make me think this is a slope. It's the change in y over the change in x. It just helps me, because if you start dropping it too soon, you start beginning to lose, what is it that this is actually telling me? All right, so this will be the limit as h goes to 0 from the left. F of 0 plus h, that's going to be 0 plus h quantity squared. Minus f at 0 is 0 squared all over h. So that's the limit as h goes to 0 from the left of h squared minus 0 over h. So that's the limit as h goes to 0 from the left of h, which is 0. So the slopes as we move towards f of 0 from the left are going to be close to horizontal. Okay? Let's look at the right-hand derivative. Now, before we do all the work for this, let's see. We talked about this at some point. Maybe I just talked to you about it. When you asked me a question the other day, and I was like, yeah, look, what is the slope of this going to be? 3. So the derivative had better be 3, assuming that this is continuous. And is it? Well, if I substitute in 0 for this, I get 0. And if I substitute in 0 for this, I get 0. This is going to be a continuous function. So the right-hand derivative should end up being 3. Let's show that it is. So I'll have the limit as h goes to 0 from the right of f of 0 plus h minus f of 0 all over h. That'll be the limit as h goes to 0 from the right of 3 times 0 plus h minus f at 0, we're using the x squared, so that's going to be 0 squared all over h. And that'll be the limit as h goes to 0 from the right. You'd end up with just 3h over h, right? So that'll be the limit as h goes to 0 from the right of 3. And 3 is like, I'm unaffected by what h does, right? So that's equal to 3. So the left-hand derivative is 0. The right-hand derivative is 3. Those don't agree. So since 0 is not equal to 3, f has no derivative at x equals 0. Yeah, that's all there is. Let me show you real quickly what this looks like. Do you guys know how to graph piecewise functions on your calculator easily?
You taught us in the video.
Oh, did I show you that
What
in
is easily?
one of the videos? Okay, I've lost track of. You like show me anyways?
Yeah.
So I'm going to have x squared, and what I'm going to do is multiply that times a test. X is less than or equal to 0. It's second math. I want less than or equal to, which is number 6, 0. What that test does is if it's true, it returns a 1. If it's false, it returns a 0. So if it's false, then it doesn't do anything with this. Then plus 3x times x greater than 0. Greater than is 3, 0. Close the parentheses. I have no idea what zooming I was doing before, so I want to do a zoom 6 so that I get a zoom standard. And it's not immediately obvious that something hinky is going on at 0. So I'm going to zoom in. I'm going to zoom in at 0, 0. And there you can kind of see it. Over here, as I'm approaching this point from the right, that looks like a slope of 3. Over here, notice how, and it's a little bit hard to see, but that actually, if you were to blow it up into exactly the right part, if you have your axes like this, it looks kind of like this. It gets flat on bottom. Okay? So because the left-hand derivative and the right-hand derivative don't agree with one another, the derivative doesn't exist at that point. We will, and I think it's in the next section, talk about graphically how can you just look at it and go, oh, look, the left-hand derivative and the right-hand derivative don't agree. We'll look for things like that. But in the meantime, if I draw the rest of it in, this looks something like this. What some books will call that is a sharp corner. It's not very technical. But when you have that, you don't have a derivative at that point. Everybody's looking to see who's leaving. Okay, he's out there working on it.
Good guy.
Do you feel scared from all this?
Pardon?
Knock on the window.
No.
Where's the guy?
There he is.
What'll be fun is if there's a sudden loud zot and he's, no, not dead,
I was like, I don't think that's fun for him.
just stunned.
Heart attack.